Now let's look at exercise 6. Basically, it's quite similar to the movie one. Now we're talking about audio. And what do we have? The first one, we have the audio for a telephone line where, of course, the quality of speech is not as good as, for example, the audio CD. And this we can really quantify. So, what is the required transmission capacity for a telephone with the PCM? And here again we have to look up in the lecture slides, for example, telephone PCM, pulse code modulation. There's different variations, but what we have here when it comes, for example, to ISDN PCM, then we have 8,000 samples per second. And we do have per sample 8-bit, so 8-bit per sample. 8-bit is not too much, so you can express 256 different values. In the end, it means you can only transmit frequencies up to, I think, 4,000 Hertz, which is not too much. So let's do the calculation. So if we have 8,000 samples per second times 8-bit per sample, then again first we can simplify, get the samples away, and where we end up with is bits per second, and that's exactly what bandwidth is all about. So we can continue and say we have 8,000 times 8 bits per second, and that's equal to 64,000 bit per second, and that's equal to 64 kilobit per second. And that's what you have in your ISDN phone. Here you have two links of 64 kilobit and an additional one for control issues of 16 kilobit. That's what is now handled in a fixed line telephone in Europe. Now let's compare it with figures we have from an audio CD. So here we have now different values. We have 44,100 samples per second, and we have 16 bits per second, which is 65,536 values. Calculation is done quite similar. So if you would like to transmit a concert in CD quality, you require the following values: 44,100 samples per second times 16 bit per sample, so it's equal to 44,100 times 16 bit per second. And again, I will use my calculator. So I will type in 16 times 44,100. We get a relatively high number. I have to divide by 1,000, not by 1,024. So I end up with 705.6 kilobit per second. And if you would like to send in stereo, you have to multiply by 2, because both channels will be completely independent. So you have 2 times 705 kilobit per second. Now let's look for the second exercise, which tries to figure out how much capacity does a CD have with this kind of quality. And a CD has typically around 74 minutes audio capacity. So we have to take our values again and say, okay, we have 44,100 samples per second times 16 bit per sample times 74 minutes. And now we have to normalize and bring it to seconds, so we have to multiply again with 60 seconds per minute. And let's simplify, get the minutes away, get the seconds away, get the samples away. What will remain is a bit. Yeah, and as we are looking for byte, we have finally divide by 8. So let's do it. So we have 44,100 times 16 times 74 times 60 times 1 by 8. Yeah, we can now simplify this against that and put a 2 in here, and then we will have byte. Again, put this into a calculator. 44,100 times 2 times 74 times 60. So these are the required bytes. I will divide it by 1024. So I get 2 kilobyte. And once again, divided by 1024, I will get to megabyte. So what I have is roughly 373 megabyte. Now I have to multiply it with 2 because we have typically stereo, and then we have 2 times 373 megabyte, which is 746 megabyte, if I've done this correctly in my head. And that's what a typical CD, what the capacity of a typical CD is all about.